Uh, so yesterday we had learned what is T T test, right? And we learned the different types of T tests. Correct? Yes. So today we are going to start with doing T test on R, right? And there will be two ways we will do t-test. In fact, all the tests. One is using RStudio approach. The second one is the R Commander, right? Using the R Commander package. Okay, just give me a minute. I think my RStudio stuck. Okay, now can you see my screen? Right. So I have explained three types of t-test yesterday, right? And they are one sample t-test, wherein you compare a sample to test whether it is part of the population or not. Example, a researcher wants to determine if an average eating time of a standard size burger differs from the set value, means the historical value, that is 10 minutes. Okay, so historically the population mean is 10, right? And now we want to test whether this the sample that he has collected, wherein for an average eating time of the burger, right? It is it still 10 or is it different? Is it different from 10? Okay. Now, can you construct a null and alternate for this quickly? I want you to construct null and alternate. This you can take it as practice, right? Quickly. What should be null and alternate for this? So let me, I think nobody is constructing it. Okay, null is equal to 10 and very good. Yes, Alok, you're right. Null is equal to 10 and alternate is not equal to 10. Okay, correct. Yes, right. Okay, great. So second type of test that we learned yesterday was independent two sample test, wherein we compare the means of two different samples and check whether they belong to the same population or not, right? For example, average height of the male employee, comparing the average height of the male employee to that of the female employee. Quickly, can you construct a null for this? Null and alternate. Null means no change. Remember the words no change or no difference. As is, no change or no difference. Yes. So correct, Amatullah, you're right. So I think you can easily construct now alternate, right? Uh, no. Amatullah, this is null. Male height is equal to female height is null. Okay. See equality, Amatullah, equality. Remember, you are putting equality in alternate, right? I told you just remember two sentences and you will never make a mistake. What are those two sentences? Equality will not come in null. Sorry, equality will not come in alternate. Equality will only come in null. And second, the claim that is to be tested is the alternate. That's it. Remember these two sentences, you will never ever make a mistake. Whenever you create a null and alternate, this is for everyone. Just weigh or just test whether these two sentences are, I mean, the null and alternate that you have constructed, are they meeting the conditions in these two sentences? That's it. Is that okay? Everyone, is that okay? No response. Okay, fine. Okay, last. Comparing the productivity, the third was dependent or paired sample t-test. And what is the speciality of paired sample t-test? Before and after condition, right? We compare the means of samples before and after a condition or before and after a uh, event happens in between, right? For example, a training happens in between and you compare the uh, productivity levels of the training of the participants before and after the training, right? So this is, so can you tell me what will be the null here? Quickly, null and alternate. Okay, as you construct it now, will I have shared null is productive level before equal to productive level after. Very good, Idris. Yes. Alternate is they are different, right? Or okay, they are different. Or if we want to test whether the program was successful or not, then in that case, alternate will be that the productivity level after was more than the productivity level before, and null will be that less than or equal to. Okay, is that clear, everyone? Okay, now I have shared some data sets with you yesterday. I hope all of you have taken those data sets. So let's by start with this example. Okay, start by reading this example quickly, and the data sets are shared with you. I want all of you to use those data sets. And second, I am hoping everyone has installed R Commander. We will be using R Commander now later on. Please don't say that I have not installed. I got that installed to everyone yesterday. Okay, please, let's start. A mobile manufacturing company has taken a sample of mobiles of the same model from the previous month's data, right? So he has taken a sample of mobiles of the same model for the previous month's data. They want to check whether the average screen size of the sample differs from the desired length of 10 centimeter. Okay, so this is the data that I have collected from 10 data of 10 mobile phones, right? Now I want to test whether this sample size, right, differs from the average desired length, which is 10 centimeter. Okay, so let me see who can construct null first. Null and alternate. Notice the keyword here is differs. I'm giving you a hint. Differs. Kanupriya, can you construct alternate as well? Okay, let me show it to you. I don't know why are you taking so long. Correct. Length is not equal to 10. Very good. alternate is screen size not equal to 10. Yes, correct. Right? So let's see. Null is the mean screen size is equal to 10. Mu is equal to 10. Right? Alternate is the mean screen size is not equal to 10. As simple as that. Clear? Right? So now let's go to R. I want all of you to go to R and quickly pick up this sheet, and I'll tell you the sheet, sorry, the Excel. It's screen size data one sample t test. Quickly pick up this sheet. I'll also, this is a Excel file, so I will activating read Excel and using choose file, or you can also use import dataset as you wish. I'm using choose file and I am okay. So if I view this, I want you to quickly do it till view. I've just given the second option of importing. You can choose either of them, right? So don't do both of them using import dataset. Okay, I've already told you. So forget this. Either you can choose either. So view it. After viewing, I'm attaching this mob size, and then I have written null and alternate, which I've already shown it to you on the PPT. Okay, I did not ask one question here. When you constructed this null and alternate, I should have asked, is this a one-tail test or a two-tail test? Once you do this, write the code till here. Let me know if it is a one-tail test or a two-tail test. Everyone with Alok? Okay, great. So this is all we have already written. If you want to write it, I'll just share it with you. Null and alternate I've shared so that you don't have to write. Right now, we are going to construct. Now we are going to do a t-test. Right? Everyone has done till 117. Let me know if you're done till 117, or I mean, basically you have run this attach command. Please type 117 if you have run attach. Can I get some more confirmations? Because if you want me to wait, you'll have to tell me, right? Because I am assuming that if I get 5 to 6 responses, then I will proceed. Okay. So I've got 4, couple of more responses, and then I'll proceed. If you have viewed and you have attached, kindly confirm by typing 117. Okay, fine. I think great. Thanks for the confirmation, all of you. Okay, fine. So let's conduct a t-test. The command is very simple, t.test. First, I will mention the data. Alternative, it's a two-sided, so you mention alternative equal to two-sided. I mention the mu, that is the mean, and is it a paired sample t-test? No. So I mention paired equal to false. That is it. All you have to do is write this command and you are done. And if I run this, my t-test is there. Look at it. There is a t statistic, degrees of freedom, p value. See, all this information is there, but all we need is just the p value. And what do we do with p value? I'm going to compare it with, what do I do with p value? Yes, we compare it with alpha. No, it is we compare the p value with alpha, right? We compare the p value. Remember, if p is less than alpha, then we, what is the rule? Okay, I'll tell you that there is a, I mean, a rhyming line. If P is low, null go. Right? I'm sure some of you would have heard of it. P low, null go. P high, null fly. Okay? You can remember this way. Let me write it. If P is low, just to remember, right? Null go. If P is high, null fly. Oh, I think I am writing. I think you did not get my message, right? You should have told me. Okay. If P is low, null go. If P is high, null fly. Just remember these two sentences in case you. So what we should do in this case? P is high. So we should we reject or should we fail to reject? Quick, quick, quick. Reject. Fail to reject. Rejection region, Pungodi, Amatullah, do you know where is the rejection region? Now don't, I mean, force me that I should take you back to the the previous class and show you the slides. Where is the rejection region? On the tail side? You are forcing me to open the, see, this is not done. Especially when you have already told me multiple times that you understood it. Where is the rejection region? Amatullah. So P is, what is P? P is 0.59. Is it greater than or less than 0.5, 0.05? Is it towards the tail or is it towards the body? It's in the, on the, in the body side, right? Greater, yeah. So what do? We fail to reject. Do not reject. Non-rejection region. Okay. Are you able to recall, both of you? Pungodi? Yes. Then why did you? Okay. Anyways, right. So since p-value is greater than the significance level, p does not lie in the rejection region, therefore we fail to reject the null at 95% confidence level. Let me give you this. Don't have to be sorry, but see, you have to be just careful, right? Before, don't just blindly reply. Okay. So, is it clear? And isn't it easy doing the t-test? Isn't it easy? Let's make it more easier with R Commander package. You will, but for this, right now there is some issue going on that if I run library R Commander, it does not open the R Commander package. And in fact, it is going to abort the session. Just hold on for a don't run library command. Okay. See, it is aborting. Can you see? So there is some issue, technical issue going on at the back end, which would be sorted soon, right? So there is a workaround to this, which we will do. I want you to search. You have to open base R, right? And for base R, you have to search. Go to search and RGUI. RGUI. Type RGUI. Go to search, type RGUI. You will get this RI386, something like this. This is base R. All of you are getting this? When you click on it, you will open. This is the interface of base R. Okay? All of you are getting this? Yes? Now here you run library R Commander. Make sure now this interface of R is not as user friendly as RStudio. Okay, if you'll not get, it's not very interactive, so you have to write the command correctly. Make sure you write the command correctly. Library, library, and so better is I copy it from here. Library R Commander with a R capital. Okay, so RCMDR and just run it, control enter. When you run it, you will see R Commander will open, the window will open up. R Commander window will open up. There you go. So let me know if you got this window open. If you got this window, type RC. RC if you got this window. R Commander. Type RC. Now there is some issue with RStudio going on. That's why this R Commander is not opening, which should get sorted very soon, right? Okay, they have already mentioned. See, warning: the window version of R Commander works best under RGUI. So it means to work with R Commander, you will have to use RGUI only. Okay. Earlier this message was not there. Maybe they have made some changes. Okay. This is October 13. That's today. Node warning. Fine. So earlier this message would not come and you could easily open R Commander from RStudio only. Okay. Anyways, all of you got this, right? So now we are going to make Idris. Why did you run R Commander in RStudio? Sorry, in R base R, RGUI. What error are you getting? Library, some library is missing. X11 library missing. I think we'll have to check that, right? So Idris, what you do is you just take a look for now, right? Let me see if towards the end I will help you and we can sort this, right? Okay, you in the meantime, you just take a look because I don't want to just keep the entire batch waiting, right? Okay, fine, right? So everyone on this window? Okay, great. So first thing you have to do is import the data, right? So go to data, import data from Excel file. Okay, name you can put the name of the data. Let's name it as mob size. Let's name it mob size and click OK. Are you with me? Means I am naming the data set mob size. Click OK. As I do this, your Explorer will open. Are you with me? Are you with me? Yes. Now your Explorer window is there. Just click on this screen size, the data set, and click open. And you'll see a script will run. Okay. Everyone is done till here? Type 1. If you're done the first step, type 1 in the chat window. 1. If you're done till here, type 1 in the chat window. You will get a message here. The dataset mob size has 10 rows. It means the dataset has been imported. Can I get some more confirmations? Or if you want me to repeat, let me know. Notice that the name that you have given, you will get a name here, name of the dataset. Can I get response, please? Because it's not that lengthy. Either you are stuck, then you let me know, or if you have done, just type 1 in the chat window. So then tell me, na Vishal, I'll repeat. I'm repeating the steps for everyone. Go to data, import data from Excel file. Is that clear? Click on it. You will get this window which asks you to enter the name of the data set. Just rename this data set to mob size. Rename it to mob size and click OK. Let me do it. When you click OK, your Explorer window will open. Vishal, are you with me? Got it? Pick up the data set. That's it. Just click on the data set, open. There, you'll see a script will run there. Now, can I get one numeric one if you have done till here? Can I get numeric one? James, Vishal. Okay, so I assume others have done it. Okay, this is the first step. In case you want to view the data, click on view. You will be able to view the data. Okay, otherwise, go to statistics. Go to statistics. Means single sample t-test will be activated. Are you with me? Type 2 if you are with me. If you have found this single sample t-test, type 2. Numeric 2. Okay. When you click on this, you will get a window like this, right? It is it has already saying that the mean population, you just have to, that this is, it is selecting the, already selecting the null alternate hypothesis, right? And null hypothesis. It is giving you null and alternate. Okay. Now, if the null and alternate differs from this, you can select the other one. But right now, our null and alternate is the same. So, but the only thing is, what is my null? Is it 0 or is it 10? Right? Change this to 10. Is it okay, everyone? Confidence level, we are going to keep at 95 because we are going to take 5% significance level. All you have to do is just click OK. That's it. After this, just click OK and your t-test is done. And you will also see the t-test. Okay, it's not coming here because we are working out of R Studio. Fine. Can you see? Isn't it easy? Yes? Okay. Actually, as most of you would be knowing that today there is a festival in India, right? So I will take a 10 minutes break here, right? And then we are going to take a 10 minutes break at around 9:15. Is that okay? Right? I'll just be back in 10 minutes. Will that be okay to all of you? Right? Today, I mean, in all, we'll take 20 minutes break, but of course, I'm going to compensate in the coming sessions, right? So I just have to be there, right, for 5 minutes. But I think on the safer side, I'll just take a 10 minutes break. Okay. In the meantime, if you really want to continue, right, or maybe if uh, are you okay with the break? All of you are okay with the break? Yes? Okay, yeah. Since I have already shared with you the this PPT also, if you want to continue, I mean, I will definitely start with example 2, right? But you can just go through example 2 and maybe see the results that I mean, how I've attempted this example 1, right? I'll just be back. I'll take a 10 minutes break and then we'll again take a 10 minutes break later, right? Thank you so much for your understanding, right? I'll put up a timer for 10 minutes for everyone. Those who want to timer for 10 minutes, right? Okay. I'll be back exactly in 10 minutes. Thank you so much. Idris, are you there? Idris, as I think we still have 3.5 minutes. So what I'll do is I'll make you the presenter. Please share your screen. Let me see what exactly is the issue with your. Let everyone come in the meantime, right? Idris, you are the presenter. You can speak as well.
Okay, I'm using a MacBook.
Okay, MacBook. Mm-hmm.
So it's bringing error that I
Uh,
need to install.
I think, yeah, I think that is just because you're using a MacBook. I think it is asking you to install something. Can you share your screen? I'm not able to see your screen.
Okay, let me see. Okay, how can I share the screen?
Okay, just click on, you don't know, there should be a share button, and then from that you can select my desktop. There should be share option.
Trying to see.
No,
No, not.
not able to.
Yes,
Okay, you're not able to do that. Okay,
yes.
fine. So no worries. I think what I'll just what I'll do is towards the end, right?
Okay, that's fine.
Yeah. Or what I'll also do is you just share, towards the end just share with me the error that you're getting. I'll look in
Okay,
Google, right, and see what how you can fix that error, right,
okay.
in Mac, right. So otherwise you're already doing R Studio
Yes,
option. It's just
yes,
that the R Commander option is not possible for you, right? That's
yes.
okay, right? So okay, you can you'll always have the recordings, right? Once you fix this error, you can practice this, right?
Okay, no problem.
Okay, great. Thanks for the understanding. So what I'll do is, Idris, can you just click on Learning Success Manager and make me the presenter? There is a Learning Success Manager with which is a host. Oh yeah, thank you. You have already given
Okay,
to me. Great, thank you so much. Okay, I think we are just left with 40 seconds, so we'll continue now. Right? Okay, let me check with everyone. Is everyone back? Can you type B if you are back? Type B because already too many yeses are there. So if you can type B once you're back. Okay, great. So I think anyways the timer is also up. Polling will do the polling. We'll do the polling in the next break. I've just taken 5 minute 10 minutes break now, and we'll take a 10 minutes break later also. Right? Okay. Great. So let's continue. Okay, all of you can see my screen, right? So isn't this R Commander powerful and easy? No coding required. Yes. Idris, I'll put you on mute to avoid the background noise. Okay. Yes. Okay. Great. So let's do the second. Let's read the second example. Example two. Right. We want to evaluate if the monthly mobile bill of males and females are different. Data is collected for the gender and their monthly mobile bills. Conduct an independent sample t-test for testing the bill amounts of males and females to test if they are any different. Are you getting the question? Did you get the question? Can you construct a null and alternate quickly? The keyword here is different, any different. Very good, Kanupriya. This is null. Excellent. alternate. So you can also write null like this. The average monthly mobile bills for males and females are not significantly different, and you write the null. The average monthly mobile bills for males and females are significantly different, means they are not equal to. Okay, this is just another way of writing. Okay, quickly now I want you to import this. Okay, but before we import this, right, see what happens is here we have two different samples coming from two different, you can say, populations for now, male and female, but we want to test whether they both male and female belong to a same population, right? Now whenever you have independent sample t test, right, you you test two assumptions. If you remember, there were two assumptions. First assumption is the test of normality. If you can recall, right, there was an assumption which said the normality is exist, a normal distribution, right? Second assumption is homogeneity of variance, right? So we are going to test these two assumptions first. And how do you test these assumptions? Test of normality is tested using Shapiro-Wilk test, right? And then test of variance is done using Levin's test. So Shapiro will test the normality, whether the data set where they are coming from is normal or not. Okay, is that clear? So quickly, I want you to first import this data set. Either you can use import data set or choose file, whatever you want. I'm using import data set, and monthly mobile bill sample. Import, right? I am assigning a name to mob bill, right? So if I view mob bill, I'm just checking whether I'm able to view it. Yes, I'm able to view it. Okay, great. Then I attach mob bill. Okay, till attach, if you're done, type 159. 159 if you're done till attach. I'll wait for your confirmations. I'm waiting for more confirmations. 5 to 6 confirmations as I get, I'll proceed. Okay, great. I've got 4, but still I'll proceed. I think everyone is with me, right? Okay. So testing the normality, as I said, it is done through Shapiro-Wilk test, right? And when we test the normality, right, we in this test we construct a null and alternate, right? So if I am testing normality, right, I will just assume that the data is normal, right? That will be my null. That the data is normal, no difference as such, right? And I will take alternate as the data is not normal. Okay, so these will be my null and alternate hypothesis. I'm sharing this uh, the content, right? The notes part, so that you can copy and paste it. Okay. So comments. I have shared the comments. Yeah. Next. Now Shapiro-Wilk test is simply using the command shapiro.test monthly mobile bill, right? When you run this shapiro.test, right? Just run this and you'll see P turns out to be 0.06. Yes. So should we reject the null? Should we reject the null or fail to reject the null? If P is 0.06 at 5% significance level, what should you do? Fail to reject the null, right? So we fail to reject the null and we conclude that the data is normally distributed. Okay, is that clear to all of you? Shapiro-Wilk test. I'm sharing the comments again, right? So we are sure that the data is now coming from a normal distribution, right? Now let's test the equality of variance, whether the variance, now equality of variance is tested when you are dealing with two groups. Equality of variance means that the variance of male and the variance of female is more or less same. Equality does not mean that they should be exactly equal to same, that they are more or less the same, right? So the variability of the groups need to be checked for comparability, right? Otherwise, if they see if the variance is too different, right, then they are not comparable, right? So then in such case we do not do a t-test. Okay. So can be checked using Levin's test. For equality of variance we do a Levin's test. In this we calculate the Levin statistics, right, which computes the test of homogeneity of variance, right? So Levin's test is a test of equality of variance test, right? So to construct to do a Levin's test, we construct a null and alternate. The null will be that there is no significant difference in the variability, right? And alternate is there is a significant difference in the variability. Is that clear? I'll share this. Though I have already shared the files, but let me share the null and alternate. Okay, once you do this, for Levin's test, you have to install a package called car. So quickly install this package car. Install the package car and activate it using library command. Once you're done till 198, let me know. I'll explain this Levin's test command. Once you're done till 198, please let me know. Thanks, Kanupriya, for the response. Others? Okay, great. So now you do a Levin's test using the command Levin test, and T is capital. So when I write Levin, I will get two options. You have to take the second option. Okay. In that, I mention the monthly mobile bill on one side, right? Tilde gender means gender is my independent and monthly mobile bill depends on the gender, right? So monthly mobile bill tilde gender, and then I mention center equal to mean, right? And run this. As I run this, notice I get a value of P, PR, probability, 88.39. Very clearly it is greater than zero point 0.5. So what do we do? Fail to reject means the variance of of male and female are not significantly different, right? So we fail to reject the null. Is that clear? Now once we have tested this, now quickly R commander, first R studio, simple t test, and since we have two variables, right? Again I mention, since we have two variables, gender as well as mobile bill, we mention mobile bill tilde gender. No, I my H0 is that there is no significant difference, right? So I will mention mu is equal to 0, that there is no significant difference in male and female. Okay, then it's a two-sided, so I mention alternative equal to two-sided, and it's not a paired, so I mention paired is equal to false. So if I run this, I'll see my p value comes to be 0.7. So what should be the result? Fail to reject the null. It means there is no significant difference in the mobile bills of males and females. Right? We conclude that there is no significant difference in the average mobile bills of males and females according to the samples that I have collected. Is that clear? Now let's, once you're done till 215, please type 215. Variable lengths differ found for gender. Is that a message you're getting? How are your variable lengths differing? Can you share the, Idris, can you share the command that you've written? I think you did not mention paired. Just check. Okay, you mentioned paired. T test mu. That's paired equal to false. Sorry, that's strange. Anybody else is getting this message? And are you getting the output? Idris, are you getting the output? Is that a warning? No. Idris, can you do this? Just shut down R and just maybe restart it and then run. I think, yeah, just restart and run. What about others? 215, if you're done till 215. Is it working? Can I get a response? 215. Can I get a response, please? Couple of more responses on if you're done till 215. Then we'll go to our commander. Okay, let's go to our commander. So go to our commander window, data, import data, Excel, name this as mob bill or whatever you want to name. Click OK. Monthly mobile bill, independent sample t test, right? Open. Go to statistics, means, you'll see independent sample t test. Click on it. All you have to do is just click on OK and your t test is done. If you have done it with R commander, type RC in the chat window. RC. If you have done it using R commander, type RC in the chat window. Okay, great. Idris, were you able to do it with RStudio approach? Okay, can I proceed to the third one? Paired sample. Paired sample, can I start paired sample? Yes, okay. See, I'm just getting response from 3 or 4 people, right? Please, I request at least 5 to 6 responses will really help me move confidently, right? I know there will be people, those who will be either uh, still lagging or maybe they are just about to finish, so they are not able to respond, right? So at least people, those who have done it, they can respond, right? So that I don't wait additional time. I'm not wasting in waiting. Okay. Company wants to measure the efficacy of the technical training. It collects the score of randomly selected 25 employees in the company. The scores were given out of 10 in the technical skill. Now working fine? Okay, great. Yeah. Sometimes it happens, don't worry, right? So this, right? All whenever you get, you think it's acting weird, just close it and reopen it. Okay. Okay. The first set of scores were collected before the training, and training happened, and the second set of scores were collected after the training. Notice this is a paired sample, before and after situation, right? So data set, paired sample. Can you construct a null and alternate quickly? Let's construct a null and alternate. Null and alternate. No one? It's so simple. Null. There is no significant difference in technical scores before the training and after the training. Am I audible to all of you? Am I audible or is the screen stuck? Then why were you not responding? Audible? Okay, fine. So, null is the training did not make any significant impact on the technical skill knowledge of the employee. Hence, mu before is equal to mu after. Okay, mu means mean of the mean of the population before the training is equal to mean of the population after the training. Okay, alternate is the training did make a significant impact on the technical skill knowledge of the employee. Hence, mu before is not equal to mu after. Is this clear? Vishal, what you have done is you put a equal to in alternate again. Vishal, did you get it? Equal to will never be in alternate. I am repeating again and again and again. Equal to can only be there in null. That is the first rule. Okay. Okay. So now here, see, I have same people, right? I have same people, set of people here, right? So there's no point I will conduct a Levin's test of variance, because same set of people are there. All I have to check is whether the data is now coming from a normal distribution or not. Okay. So what you can do is, first let's import this data set, paired sample t-test. Go to import. Paired sample t-test. It's an Excel file. Open. You'll see the scores are like this: before training, after training. I name this data set as emptrain. If I view it, you can see before and after training there are 25 observations. First, I'm going to do a Shapiro-Wilk test of normality. And the Shapiro-Wilk test, null is the data is normally distributed, and alternate is the data is not normally distributed. After this, I simply do a Shapiro-Wilk. First I attach, and then I do a Shapiro-Wilk either before training or after training, either of them. In both the cases, my P is greater than zero point 0.5. Thus, we fail to reject that the data is not normal. We fail to reject that the data is normal. So we will go with the null hypothesis, that is, the data is normal. Once you're done till 250, let me know. Sorry, 250. I'll share these comments so that. Okay. Sorry. T-test. I mentioned the two data sets or the two samples before training and after training. Make sure to run line number 261, that is attach. Then only you will be able to name the variables without the data frame extension. Okay. Before training, after training, alternate equal to two-sided and paired equal to true. Once you do this, you'll see p value comes to be this. So can you tell me how will you take the decision here? So what should be the should we reject null or why? So the p value is much lesser than this is exponential. It's do you know how to read this number? Pungodi, do you know how to read this number? Yes, right. You're right. No, 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 no. It's seven zeros on the left side, then 9578. Okay, 7 zeros and then 9578. Yes, Idris, you are right. We reject the null in this case. Okay. Okay. Is this clear? So we reject the null, that the training did not make any difference, right? Hence, it means the training was successful. It made a difference, right? And training did make a significant impact on the technical know-how or technical skills of the employees. Is that clear? Now, R commander, quickly we'll see. Go to R commander, data, import data, Excel. Let's name it as paired underscore test. Click OK. I pick up the paired sample t-test. Open. Go to statistics, means. You'll see paired sample. How to get the R commander? Did you get it earlier or you are asking for the first time? Idrissa. So you completely missed first time? Okay, I'll help you. Just wait, right? Give me a minute, right? But see, it's okay. You can open it. Let me go to your search and search RGUI. Go to your search and RGUI. You will get this base R. This is a base R. Click on this. This is a base R link. This will open the base R and it should open something like this. Idrissa, can you confirm? Those who have done, you can try doing paired sample using R commander. Right? It's pretty easy. Idrissa, can you quickly reply? Did you get this base R? Got it? Just run this library R commander. Make sure you do not make any spelling mistake. I've shared the command. Quickly run it. And I'm assuming you have downloaded, you have installed R commander earlier. That's very important. If you have not installed R commander yesterday, then this will give you an error. Okay, so R commander library, when you run it, a window will open like this. It might take a couple of seconds, but it will open because R commander is a very heavy package, right? Okay, now go to statistic others, everyone rather, right? Means paired test, and here you have to select, just make a selection before, after, or after, before, whatever. Make the alternative selection and just click OK. And you will see you get the p value. How many of you were able to do using R commander? Type RC. RC if you were able to do this test paired sample with R commander. Okay, great. A lot of you, very good. So really happy that all of you are able to do it. Anyone who is struggling with R commander, let me know. I think already Idris is able to manage. Then Idrissa, I think you are also able to manage, right? Did you get this window, Idrissa? Okay. Now I think you should have told me earlier. Now see, we have already done 3 questions on it. So just hold on. Once you open this window, Next, when we do ANOVA, I'll help you. Yeah, you launched it. Perfect. Then just keep it open. Right? Just keep it open. When we do ANOVA, you'll follow it. Follow me. Okay. Okay. Perfect. So, is it clear? The right now we are going to move to ANOVA. Right? So, remember when do we use ANOVA? Anyone who remembers? Actually, if you look at the screen, the answer is there. But if you can remember, that will be great. When do we use ANOVA? When there are more than two groups. It could be two, three, four. Sorry, it could be three, four, five, six, anything. Okay. So now understand ANOVA very well, right? It's a very interesting test. Okay. And with some peculiarity is there. So you should, just understand the peculiarity in that, right? Okay. Sorry. Suppose we want to compare three sample means to test to see if there is a difference, if any difference that exists among them. Let me give you an example. Suppose you want to test whether the number of flights on a Dubai airport, on London airport, and on a New York airport, right? I repeat, whether the number of flights on a particular day or in a particular month are, are, are the number of flights significantly different or are they not significantly different, right? Three airports, or let me take five airports, right? Dubai, London, New York, Tokyo, New Delhi. Five airports. Even then, ANOVA, if I want to test whether the number of flights in these five airports are significantly different, right? I can use ANOVA. Is that clear? When do we use ANOVA? Three or more samples. Clear? Let's interpret this statistically. Example, if I interpret ANOVA statistically, ANOVA means analysis of variance, right? So using the analysis of variance, using or by analyzing the variance, we are able to test whether they belong to the same population, all the three, all the four, or all the five, or any one of them is significantly different from the rest. Now, understand here, ANOVA does not tell you which one is significantly different. All it will tell you is whether all are same or there is any one that is different from the remaining. Are you getting my point? This is the very, very important point. I am repeating this point for everyone. ANOVA will not tell you which of the sample is significantly different from the others. All it will tell is either all are same or there is one which is significantly different from the remaining. If you want to know which one, then there are some advanced level tests which are not there in our curriculum. Is this point clear? Okay. Now interpreting this statistically, do all the three means come from a common population? This is one interpretation, right? Is one mean away from the other two so that it is likely to come from a different population? This is the second interpretation, right? It's the, second way of interpreting, but actually they mean the same only, right? And third, either all the three are so apart that they are likely to come from different populations, right? So these are the statistical interpretations. Okay. Now why do we do ANOVA? When we have to be when we have been we have been comparing two populations till now, right? What if we want to compare the means of more than two populations? In such case, we use ANOVA if we wish to compare the populations of each containing several levels or subgroups. Sometimes you want to compare the population having several subgroups. Even in such case, we can use ANOVA. It means analysis of variance, right? Now, some examples, again, though I have taken some examples, quickly we'll read through these examples. A group of psychiatric patients are trying three different types of therapies: counseling, medication, and biofeedback. You want to see if one therapy is better than the others. Okay, right? Three therapies are there. You want to test if any one of them is different from others, or are the three same. Second example, students from different colleges take the same exam. You want to see if one college outperforms the others. Third example, three groups of people were assigned high, medium, and low levels of social media. You want to test if there is a difference in the hours of sleep per night of each of the three samples. Is that clear? So three, basically three or more than three. Remember this. Clear? In such case, we need ANOVA. Now there are two types of ANOVA. One way or two way refers to the number of independent variables in your ANOVA. So in a one way, you have only one independent variable, and this is what right now we have in our curriculum. There is also a two-way ANOVA where there are two independent variables. Is this clear? Two-way means two independent variables are there. Two-way ANOVA has two independent variables, right? Okay, now what we'll do is we'll take a break, because from here it will take me 15 minutes to explain the entire process of ANOVA, right? So we'll quickly take a break, and when we come back, we will continue with ANOVA. So how is the session going? Just if I may ask you quickly, how is the session going? How did you enjoy it? Did you learn it? Right? Are you, of course, are you out of the comfort zone? That is important. Are you learning out of the comfort zone? For me, that is important. Yes? Okay, great. So I'm putting up a poll, opening the poll. Please do participate in the poll. And what we'll do is we'll take a 13 minutes break, right? We'll take a 13 minutes break, and I'll quickly, and please do come back as per the timer, right? Very important. So I put up a timer. Please do participate in the poll as well, and I'll quickly, and we'll do come back as per the timer, right? Thank you so much. Okay. Thank you so much for participating in the poll. Please do give me a confirmation if you're back. Can we start the session? Can we start the session? Okay, great. So, okay, so we were understanding the process of conducting a ANOVA test, right? So, till now we have understood why do we need ANOVA, when do we need ANOVA, right? What are the different types of ANOVA? Now we are going to understand how do we do ANOVA test using some pictures, right? And then we'll go on to Excel and see these same steps in Excel. Okay, and then we will go to R. Okay, so understanding ANOVA, the first step. See, right now, just think in terms of these pictures that there are three samples you have: blue, green, and pink, and you have their sample means x1, x2, x3. Okay, blue, pink, and green, x1, x2, x3. The first step you do in ANOVA is take all the data points together and create a larger distribution from them. Okay, so what I'll do is let me simultaneously open the Excel, right? See, here in Excel, I have, so this is our example, right? So I'll move simultaneously example as well as this explaining the concept in pictures, right? So we have four stores, sorry, we have four regions and five stores in each region, right? We want to test the following table. You're randomly given five stores. You have to test whether the sales in these regions, right, across the stores, right, is it significantly different across these four regions, right? Region 1, Region 2, Region 3, and Region 4. Are the sales significantly different, or are they same, right? So first step you do is you take all the data points and create a larger distribution from them, right? Means you just pool all the data points and you create a larger distribution from them. We need to check where is each sample mean related to the overall data set in the background. So in the background you can see this becomes your bigger data set, the one in the blue, right? And the dotted line becomes your grand mean, means the mean when all the data is pooled together, that is called the grand mean. Is that clear? That is the first step. Then what we do is we calculate the variability between the means. Means between the means means each sample mean, I test the variability of each sample mean with the grand mean. Means I test whether how much far is this mean from the grand mean. Okay, we analyze the variability of each of the sample mean from the mean of the combined population data set called the grand mean. Is this clear? This is called variability between the means. Difference between grand mean and the sample means. Correct, Vishal, you're right. Right? This is called variability between the means. Is it clear to all of you? What is variability between the means? Okay. Now, next step. See, this is just a case. This is not a step. It's a case. If there is a data set, like let's say green one, right, which is significantly different from the grand mean, right? So we conclude if we if there is such data set, we are able to conclude that the third mean does not belong to the overall population as the other two belong, right? So if there is a third mm, this third one, if the mean of the third one is significantly different from the grand total, we will conclude that this green is behaving significantly different, or it is significantly different from the overall population as the other two belong to them. Okay. Now, however, now if two of them are significantly different, then we can conclude that the means belong to different population. Okay. If they all belong to distinct or different population, so the variability will be very high between them. Okay. Now, what is the null hypothesis here? If the variability is not significantly different, means this green one, blue one, and pink one, they belong to a population which is similar, right? In such case, mu1 will be equal to mu2 equal to mu3. Mu1 means population mean where which blue belongs to. Mu2 means population mean which pink belongs to, and population mean which green belongs to. That is mu3. Is this clear? Right? If the variability is not very far or very different, this holds true. Yes. So null hypothesis is whether or not three means are likely to come from the same population. Right? That is our null hypothesis. That the three, or rather, I would say, null hypothesis is that the three means are likely to come from the same population, and this will be your null hypothesis. Okay. Thus, we want to test if the means of the population from which these come from is significantly different or they are same. Is this clear? Variability between the means. This is called variability between the means. We are right now discussing variability between the means. Now let's understand it. We have seen the variability between the means, wherein we calculate the variability of each data set or each sample vis-a-vis the grand mean, right? Now let's see variability within the means. Now what is this variability within the means? It is the spread of the variance or the spread of each distribution, right? Means what is the spread of blue, what is the spread of pink, and what is the spread of green. Is this clear? What is the variance of blue, pink, and green in itself, not among, but within it, within themselves. That is why it's called variability within the means. Here, now think, ANOVA is simply the ratio, variability ratio, wherein in the numerator we have variability between the means, and in the denominator we have variability within the means. Okay, is this clear? Yes. Okay, Idris, what I'm saying is pictorially this is variability between the means. Yes, with the overall mean or the grand mean. Yes, how much is the variability of the three? Then we calculate the spread or the variance of the individual samples in itself, x1, x2 and x3. Okay, ANOVA is simply the ratio of these. Means in ANOVA is simply the variability between the means divided by variability within the means. Is that clear? Okay, so you can see this picture, distance from the overall mean, and this is the internal spread of the data, right? This is the ANOVA, same thing. Variance within, between upon variance within. Okay, this gives you a F statistic. Variability between upon variability within will give you F statistic. Okay, okay. Now, how do you take the decision? Now think, if variability between the means, that is the numerator, right? Distance from the overall means or the grand mean, is relatively large compared to variance within the samples. Okay, in the denominator, the ratio will be greater than 1. Yes, if the numerator variability is much larger than the variability within, means the ratio is going to be greater than 1. Clear? This point is clear. What I'm saying is, if this variability is greater than this variability, my ratio will be greater than 1. Yes, very logical. Is this clear? Okay. Now, what does this indicate? This indicates that the samples most likely do not come from a common population. Means because the variability between the means is larger, numerator is larger, this one, this is large means x3, x2 or even x1, they are coming from different populations, right? Only then numerator can be greater than 1, isn't it? Are you getting this point? It means if they come from different population, we reject the null. So it means if the F statistic, this, if the F statistic is greater than 1, we reject the null. Is that clear? And conclude that not all the means come from the same population. Okay? This point is clear? So let's see the three cases. First case, which I already discussed, numerator is large, denominator is small. we reject the null because all the three, or at least one of them, does not belong to the, or one of them is significantly different than the remaining, right? At least one mean is an outlier, and each distribution is narrow, distinct from each other, right? Second case, if they are similar, we fail to reject. Means the the means are fairly close to the overall means, and or the distributions overlap a bit, hard to distinguish. Yes? Are you getting this point? If they are fairly same, right? Variability within the mean is similar to that of variability between the means. So it means they are fairly same, right? And the third case, if variability between the means is smaller than the variability within, right? We fail to reject the null because here also the three, we fail to conclude that any one of them is significantly different from the remaining. Now they are close. They are relatively close. Means that they are very close to overall mean, and or distributions, or you can say they melt together, or they are just very close that they gel together. Is that clear? The what happens at the background, or what happens at the back end, is this clear? This is just a explanation of what are the steps, what are the calculations that you're doing. Okay? What are the calculations that is done at the back end? Okay? So this is what F is: variability between upon variability within. Variability between is the red arrows, and variability within is the blue arrows. Okay, so what we'll see now, we'll go to this Excel and just we'll see how this is calculated, right? Okay, so we have 4 regions, 5 stores in each region, and the sales are given on a particular day, right? I've calculated the mean 1, mean 2, 3, and 4, right? I calculate the grand mean first. Okay, and I calculate the standard deviation of each of these. Okay, clear? So what do we do? First, we construct a null and alternate, stating that there is no significant difference in the mean sales of the 4 store locations, right? So mu1 is equal to mu2 is equal to mu3 is equal to mu4, and h1 is there is a significant difference in the mean of at least one of them. Okay, so how do we calculate first the SSA, that is between the groups? See, how do you calculate? You calculate using the formula number of items in each group wait number of items in each group multiplied by mean of the group minus grand mean whole square plus same for every group. Means this, right? Number of items 5 multiplied by C10, which is mean of C divided by this minus grand mean, right? So what I'm doing here is from each mean I'm subtracting the grand mean, okay, and multiplying it by the count of observations in each data point. Is this clear? This will give me sum of squares of SSA, sum of squares of um, sum of squares among, or it is written among here, but it is like between the means, okay, between the groups you can see, okay. I'll come up with a number here. Then I calculated, then I calculate sum of squares within the mean. Is this clear? Now within, what I do, I simply calculate among them what is the uh, difference each number from its mean, and then I calculate the sum of all of them differences, sum of squares within the mean, okay. Now I divide this sum of squares between and within by the degrees of freedom they have, and degrees of freedom are C minus 1 for among or between, right? C, where C is the number of, I think C is the number of groups, one, 2, 3, 4. Then you have N. N means the number of observations in each group. Okay. So from these, you divide the numbers that you've got between and within, you divide by their uh, degrees of freedom, and you get some number. Simply you divide these numbers and you get a F statistic. So notice between the mean is in numerator, and within the within the mean is in the denominator, okay, and you get a F statistic. Now you just look at this F statistic in F tables, which are for alpha equal to 5, and you get the F, you get the p value, right? And then you check the p value, you compare it with the uh, significance level, right, alpha, and you take the decision, okay. So that is the process, right? So but you don't have to do this long process, you don't have to do at all, and neither you have to understand, right? So what you have to do is, we'll go to R quick, right? Let's go to R and just pick up this file ANOVA underscore test and name it as CMB group, combined group, right? So what I'll do is, I'm going to import this file using import dataset Excel. You have ANOVA test. Pick up this file ANOVA test. Open, import. So you get this data. I want all of you to please import this data and name it as CMB group. When I view this, I get this. Hope this will not have to do. No, 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 not at all. Idrissa, not at all. You don't have to do it manually. See how you have to do. Just import the file and one command and it is done. All you have to do is just compare P with P value with the alpha. Okay. We used to do this 10, 15 years back, right? When big data was not, I mean, these softwares were not that robust, and some of them did not exist even at that time. Okay, so once you have imported, type 287 in the chat window. 287. Once you have imported, type 287. Okay, so after that you would have maybe taken a look using view, right? Now here you have seen the data has come up this way, right? So before you run ANOVA, you need to uh, stack the groups. Using the command stack, you will be able to stack these groups one below the other. Okay, so okay, I think okay, what are these groups? I think I did not read the question. We are analyzing the stress level of individuals who were laid off at three intervals, three situations: normal situation, when the layoff was announced, and at the time of layoff. Okay, so this data is representing the stress levels at the in a normal situation, at the time of layoff, and during the layoff. Is this clear? We want to understand if there is a difference in the stress levels during the three situations, if they are significantly different or not. Did you get the question? Right? So ANOVA test dataset we have imported. Can you tell me the null and alternate here quickly? I want one of you to tell me, or maybe more than one also. You are free to tell the null and alternate. Same level of stress at the in three different situations. So you'll say there is no significant difference in the stress levels. The stress levels of the employees are not different or significantly different at different situations. That is, they come from the same population, right? And H1 is at least one of them is different from the others. Are you getting it? You will say at least one of them is different. Okay? Is this clear? Null and alternate? Okay, next. Now, this is our data, three different situations. First thing you will do is stack. Use stack command and it is going to stack the data. So if you see this stack data, this is how your data is stacked one below the other. Is this clear? Just stack it and see if you are able to see a stack group. Tomorrow we will be doing regression, okay? Okay, 301. Can I get more responses? Okay, great. Thanks for the response. Doing a ANOVA test is simply just one command. The AOV means ANOVA. I mentioned the variable names, values tilde ind. Now this is values tilde ind. And I mentioned the data equal to stack groups. That's it. Run it and run this line number 306 summary of this model. When you run the summary of this model, you get this. In this, p value is this one. All you have to look is p value and tell me the result. Do it quickly. P value is less, so P low, null go. Means we cannot go with the null. So we reject the null. Okay? Everyone with me? Now quickly see the R commander approach. Go to R commander, statistic, data, import data. Once you get this, let's name it as AOV test, ANOVA test. Click OK. I'll pick up. See, I'm picking up R commander file. Notice, it is already a stacked file. Okay, the only difference is in R commander you have to import a stacked file. So this is a stacked file, that is why I'm picking it up. Click on this. Once you have done, you can see go to statistic and variance, uh, contingency table. Sorry, go to means. Contingency table is for chi-square. Means one-way ANOVA. Click on one-way ANOVA and all you have to do is just click OK and you have the result. Same result. How many of you got ANOVA from R commander? Type RC. RC if you have got ANOVA from R commander. Only two have done. Quickly, we have to complete chi-square and start. Is it done? Only two of you could do it. Three. Okay, so this is clear. R commander approach in Idris statistics means you will find one-way ANOVA. Got it? Okay, great. Thanks for the confirmation. Okay, so ANOVA is also done. Now coming to non-parametric, and the only non-parametric we have to do is chi-square, right? So chi-square measures, see, first of all, remember it's a non-parametric test. So what are the features of non-parametric? You know, right? There are either ranks or outliers. We deal with median. We are dealing not with numeric data. We are dealing with some data that is not normal. Okay, or there are categorical variables. Okay, so chi-square is a measure of association or relationship between two categorical variables. Okay, for example, gender-wise preference for location. If you have data around gender-wise preference for location, okay, it's like gender-wise preference for three locations. Okay, so both gender and location are categorical variables, right? You cannot calculate a mean for them. This is developed by Carl Pearson, applied in on two variables that are nominal in nature or of interval data that has been categorized into small groups. Okay, compares observed frequency with expected frequency. We'll see what are these observed and expected. Observed frequencies are the actual frequencies. They have been actually observed. And uh, expected frequency, we'll see how we calculate it, right? Determines that two variables are independent or related, right? It determines that the two variables are either they are independent or they are related. Used when two variables are nominal in nature or we convert our interval or ratio data into small number of categories, right? So either the numbers are nominal in nature, exist already, or if there is a continuous variable, you convert them into interval data, like bins in histogram. Okay, is this clear? Okay, now this is a formula for chi-square. You don't have to remember it, but I'll show it to you with example, right? Assumptions. The data is randomly selected. It should be sufficiently large. Actual count of data is needed. Count of data is needed. Okay. Adequate cell size means each observation should have some weight. It should not be very less. Okay, or a very small number. Observation must be independent. Do not does not prove a cause and effect relationship, and no assumption about the shape means no assumption about the. Okay, so there is no assumption about the shape means It can be normal or it may not be normal. Okay, it may not be normal rather, right? So in chi-square, the hypothesis or the null hypothesis is the two variables are independent. Let's assume that the two variables are independent, and the other way is, sorry, the alternate is the two variables are associated. So let's read through this question and we'll see how we calculate chi-square with this. Quickly read through this. In a city, flu vaccine was administered in sequence over a period of 2 months. A simple random sample was collected for 1,000 city inhabitants. Some of the people received 2 shots of vaccine. Some appeared only for 1 shot, while others received neither. So there are 3 cases: flu, flu vaccine. Oh, sorry, they got flu or they did not get flu, and whether vaccine was administered, no vaccine was administered, 1 shot was administered, or 2 shots were administered. So this is a frequency table which is showing you the count of these buckets, right? Is this clear? So this is showing you the count, right? So what you have to do is there a evidence that vaccine classification and the occurrence of the flu are related, right? So what we want to do check is whether there is any degree of association between them. Okay, so assume I have already shared. Did you not get this? Again, it's the same issue. I don't know why. I shared that yesterday. Now, all this did I share? Do you have all these files? Do you have all these files? Yes. See, everyone is having. Okay. R script also I shared. Okay, no worries. I'll share the R scripts also. But I did share. Anyways, I'll just check. Okay. So first, the null is there is no association between vaccine classification and the occurrence of flu. Right? No relation. No association. Then H1 is there is an association between the vaccine classification and the occurrence of. Okay, there is an association between these, right? Now we calculate the we are going to calculate the chi-square. Now this is again at the back end that happens. You don't have to do it, right? How do we calculate chi-square? If I just take you back, this formula helps you calculate chi-square, wherein you subtract expected frequency from observed frequency and dividing by expected and then doing a summation of it, right? Squaring them up, dividing by expected and doing a summation of that. This will give you a chi-square. Is this clear? Right? So now how do we, yeah, this was the formula. Sorry, I was there, right? Now let's calculate this chi-square using this formula. Okay, so what we do is blue one are observed frequencies. If you see 24, 9, 13. So 24, 9, 13, 289, 100, 565. So these are observed frequencies which actually were observed, right? Now, how do we calculate expected frequencies? These in red are expected frequencies. How do you calculate expected? For this expected frequency, right? This in first cell, I will I'm going to multiply 313 with to get this 14.4. I'm going to multiply 313 with 46, okay, divided by 1000. Are you getting it? That's how you get 14.4. Look at this. Very simple. This will give you the expected frequencies. Similarly for other cells. For this one, right, I'm going to multiply 578 with 954 and divided by 1000. This is going to give me 551.41. Is this clear? How do you calculate observed and expected? Right? Degrees of freedom is calculated using this formula, rho minus 1 multiplied by column minus 1. Now once you have got these observed and expected, this is just the calculation. Chi-square is adding all of them, summation, remember? Observed minus expected divided by observed. Sorry, divided by expected, right? So it will give me the value of chi-square once I add all of them. Okay, so this comes to be 17.31, and at 2 degrees of freedom is going to give me this result. Okay, but again, this entire procedure we don't have to do it. R will manage it. Okay, let's see how we calculate this in R. Pretty simple. Pick up this data and name it as CHQ. Wait, I have to import it. Chi-square data. Take this chi-square data. Ignore chi-square ANOVA. Chi-square data. Open. And you'll see 1000 rows would be there. Import 1000 rows. So once this data is there, I'm naming it as CHQ. Attach and view. So my data is there. I create a frequency table. Notice, from this I'm creating a frequency table using table command. And this is how your frequency table looks like. Okay. Now once you've created this table, just use this command chi-square dot test and name the table. That's it. You'll see a p value coming up. And so quickly do it. Once you're done till 3:47, let me know. And tell me the decision also that you will take. James, I will explain. Degrees of freedom is simply the independent values that you can uh, the independent values that can be put in any data set, right? It's usually n minus 1, right? Usually, not every time. Rest, I would suggest you have the PDF also, right? Go through the explanation with an example. Yeah, you will get it. Okay. Okay, once you're done till 3:47, let me know. Chi-square test, if you have done, type 3:47 in the chat window. We reject the null. Very good. Because P is very small compared to 5% or 0.05, thus we reject the null. Is this clear? Okay, great. Then I would request all of you to try chi-square test in RStudio. You can do it very easily. Okay, let me show it to you. Quickly, I'm going to go fast here, right? So you can see, and it's pretty simple. Excel, I name this chi-test, chi-square data I pick up, go to statistics, contingency table. Yes, wait, I think chi-square contingency table, two-way table. Select and click OK. That's it. So you have to go to contingency table for chi-square. Okay. Okay. So inferential statistics is done, right? Long topic, I know, but yes, hopefully this inferential statistics, once you go through it again, it will really help you form a strong foundation to the models that we're going to do from tomorrow, right? Okay, then next. Now we have done inferential statistics. Next thing we are going to do is something called data validation. Okay, fine. So train and test. Yes. Cross validation. Okay. Now see, Shakti. Sorry to interrupt, sir. The session 5.2 para script file is not in community. I'll share it, Shakti. Right? Let me know which file is missing. I'll share it. But let's do it. Remind me towards the end. Right? So now we have done hypothesis or inferential statistics, right? Now tell me, we spoke about sampling, right? There are three ways of sampling, right? That you usually follow. In fact, there are only three ways of sampling, right? And Either you do random sampling, right, or you do systematic or stratified, right? In random sampling, I am simply picking random samples, right? N random samples. I simply pick n random samples that I, okay. In systematic sampling, you follow a pattern to pick the samples, okay. You follow a pattern. We'll discuss that pattern shortly. And the third type of sampling is stratified sampling, wherein you maintain the ratio of subgroups in the population. When you pick a sample, you maintain the ratio of the subgroups in the population, right? Let's see all the three with the help of an example. Let's say we have, this is a population, right? 10, population of only 10 people. 6 of them are male, 4 are female. Clear? Till here it is okay? Okay. Now how do we do random sampling? I simply pick 3 observations. Random sample 1, 1, 3, 9. So 1 is male, 3 is male, and 9 is female. So 139 is random sampling. First sample. If I ask any other person to pick the sample of 3, will he pick the same one? Do you think the person is going to pick the same random sample? Tell me. Do you think if I ask 3 of you to pick a random sample of 3 from this, you are going to pick the same sample? No, right? So random samples, these are random samples. One of you pick this, second pick this, third pick this, right? So that's called random sampling. Then you have systematic sampling, wherein you create a system, you create a pattern and then follow that pattern. For example, every third observation, I'm going to pick 1, 4, and 7. Okay? Or someone can, or I can also pick 3, 6, 9, 4, 8, and 2. Okay, got it? Systematic sampling. Then third one is stratified sampling. What happened in stratified sampling? I have two subgroups, male and female, right? So when I pick a sample, now when I in this I will not be able to pick a sample of 3 because I will not be able to maintain the ratio, which is 6 is to 4 or 3 is to 2, right? I'm going to, let's say, pick a sample of 5, right? So if I have to pick a sample of 5, I will make sure that I pick 3 males and 2 females so that my ratio of male to female is maintained. Is this clear? That's called stratified sampling. Are are the three sampling techniques clear? Random, systematic, and stratified. Please explain systematic and stratified. Okay, Idris, systematic. See, random is simply I'm picking randomly 3. Systematic, I follow a pattern. Like every third observation, I'll pick 1, 4, 7. 369,482. Is this clear, Idris? Right? I'm following a pattern. Okay, then stratified. I have two subgroups in my data, male and I maintain in stratified, I maintain the ratio of the subgroups. What is the ratio of male to female, Idris? 6 is to 4 or 3 is to 2, right? So in stratified sampling, I am going to pick up, let's say I want to pick up 5 observations, right? And maintain the ratio of 3 is to 2. Okay, so I will pick, see, I have flexibility within male. Pick any 3 male and pick any 2 female. So here also I'm pick any 3 male and then pick any 2 female. Is this clear? Okay, now, okay, so we have done inferential statistics, right? Now, understand what happens. Let me take you to this example, right? See, from the population to infer or to create a model also, right? To create a model, let's say we want to create a regression model, right? For the data and deploy it in a real situation, right? So what happens? Let's consider this example. My population is 100,000 or 1 million, right? From this 1 million, to create a regression model, right? Or let's say any other model that I want to create so that I'm able to, so that my model is robust enough to be used to predict the future scenarios, right? So to create a model, I pick a sample of 1000 observations. Clear? 1000 rows, right? Now, see what happens from here. If suppose I use this 1000 rows, right, to create a regression model, right, which is going to predict, let's say, the price or the any y variable, right? Suppose I use entire 1000, right, and I deploy that model in a real scenario. What if the model was not good enough, right? I have deployed it, right? What if the model is not robust enough or good enough? So I will have to take it off from the live environment. Yes, from the live environment where I have deployed the model, I will have to take it off. Yes, and then rework on it because the model was not correct or not robust. Are you getting my point? Yes. So what we do is we don't create a model on the entire sample, right? We split the sample into two parts, test and train. And this splitting of sampling this splitting of sample is called cross validation, right? So what I'm going to do is instead of 1000, I'm going to split this into train and test, wherein I use maximum as many as possible in of these observations in train. Now you don't ask me that you why did you put 800 and not 900. See, I need some observations, some decent amount of observation to test it also, right? Right. So before I create a model on 800 rows or 800 observations instead of the 1000 observations, right? So when I train this model, creating the model is called training the model, right? I train the model on 800 rows, and then before deploying it in the live environment or deploying it in a real situation, I will use this test data and put it in the model to check how accurately my model is predicting. Is this point clear? Is this point clear? Why are we keeping test 200? Right? Now this 80-20 is not a, uh, you can say it's not a hard and fast. I mean that you have to keep it 80-20, right? You have to use your judgment, and this judgment comes with time as you work on more models, right? That when do we use 80-20, or maybe sometimes we use 70-30 or 75-25. Basically, your training data should be able to capture as many different scenarios as possible. Only then the model will be robust enough. If suppose training data miss some critical uh, scenarios, right? And those scenarios come in the test data. So do you think my model is going to predict them correctly? They were such scenarios were not able to. I mean, the model was not, uh, or sorry, such scenarios did not exist in the trained data, right? But they came up in the test data. So my model will not correctly predict those scenarios. Okay, is that clear? So, but at the same time, if I say like instead of 80-20, let's say I do 90 and 10, right? So you have to maintain that ratio. If I do 95, 950 and 50, then my test data is not good enough because test data is very small then, right? So we have to maintain that balance, that, and that comes with time, that how do you maintain that balance. As I said, as you will work on more and more models, you will get an idea where how many uh, data points I should include in train data and how many data points I include in the test data. Okay, right? So this process of splitting before you uh, start uh, building a model, we do a cross validation. This process of splitting it into test and train is called cross validation. Okay. Okay, so this is what cross validation is. I've already explained, but let me quickly run through it, and then I think tomorrow we will do cross validation. I think we have time, we'll be able to do it today. Okay. The test train split of is a technique of evaluating the performance of a machine learning algorithm, right? So on that, when you create a model on train data and you deploy that model on the testing data, right? You check what you are doing. You are basically checking the accuracy of the model in a simulated environment or in a not so. Okay, so what you're doing is you are testing the accuracy of the model in a not in a live environment, but in a simulated environment. So if suppose the accuracy is not that good, would you deploy that model? Suppose my model is not able to, I mean, my model's accuracy is 50%, 40%. I will go back to the training data, I will reconstruct the model and then again check it. Otherwise, um, if I would have not tested it, or I would have straight away deployed it in the live environment, it would obstruct the live environment, plus the accuracy is not good enough. Is that clear? Right? That is why we need this cross validation. Okay. Okay, it can be used for classification or regression problems and can be used for any supervised learning algorithm. What is supervised learning? We'll see it in maybe tomorrow or in next class, right? The procedure involves taking a data set and dividing it into two subsets. Okay, the first subset is used to fit or build the model and is referred to as training data. The second subset is used to train the model instead of the second, yeah, subset is not used to train the model. Sorry, the second subset is not used to train the model. Instead, it is used to uh, test the accuracy of the model. Okay. So train data used to build machine learning model. Test data is used to evaluate the fit of the machine learning model. Means how how accurate the model that you have created is uh, is predicting the data that is new to it, right? Test data is new to the model because it was not built on test data, right? Yes, the model was built on training data. Test data is new to it, isn't it? Right? Okay, so this is what, there is some more theory which I have already explained around test and train. So what we'll do is we'll go into splitting. Hmm. Okay, this is all that I have already explained, right? So this is how you do splitting or the cross validation. Okay, so for cross validation, first install this package. I think you have already installed this CA tools. Have you installed CA tools? If not, quickly install this CA tools. If you have installed, just activate it using library command. Activate it using library and also activate ggplot2 package. Once you have activated ggplot2, call data diamond dataset using data diamond command. Call this, and you can check the structure to just understand. Structure. Once you're done till structure, let me know. Line number 46. If you're done till structure, line number 46, let me know. I'll just take 2 more minutes and then we'll close today's session. Okay. Okay. There is one more thing that I have to explain. Everyone, can you see this command set.seed? Right? Why we want? Because we will be working out for diamond data set. No, 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 no. We did not active. Pungodi, I told you every time you have to work with a data set, if within the session, suppose you are working on RStudio right now and you have activated GG plot, right? ggplot, right? Or you have activated diamond dataset right now and you are working throughout. Then you don't need to again activate the package. But today we did not activate this package. Did we activate this package today? Did you work on this package today? No. So that's why you have to activate it. The time it is basically whenever you work with it, you have to activate it. But of course, if you are working it now and after an hour again you are working it, then you may not, unless until you have closed the hour in between, then you may not work it again. Okay? Right? Okay. So all of you can see this set seed, right? Now what is this set seed? Let me explain. Yeah. Set seed sets the randomness of the data when you select it. What does this mean? Let me take you to the same Excel. Okay. Sampling. This one. Right? Let's see this random sample. Right? I ask all of you to pick a random sample from this data. Random sample of 3. Right? Do you think all of you will pick the same sample? Okay, no, right? Now you are working on this data and you have run this splitting command, right? To split the data. Okay? You have run this command to split the data. This splitting is also done randomly, right? Splitting is also done randomly. It will split 75% in one part and move it to train, and the remaining 25 also it will move to test. But this splitting happens randomly. Okay. Now think of a situation. Today you created this model wherein you have done the splitting, right? And based on this the model has been created, right? Now tomorrow or day after, some of a colleague from your team, he wanted to go through this, or maybe your manager after 3 days or 5 days, he wants to go through these files, right? Or go through this model, and he runs the model, right? Again, he runs this command, right? Sample split. Again, he runs it, and do you think he is going to get the same? He's going to pick the same observations. It's a random split. Only the ratio will be maintained, but the observations will not be picked the same one. Are you getting it? Right? Suppose today you created a model, tomorrow you want to iterate it, you want to test it, and you are running the command sample.split again. Right? You are not going to pick the same observations, isn't it? Because it's a random picking, it randomly picks the observations, but maintain the ratio. Okay. Now, what does this set.seed does? Right? It fixes the randomness of the data when you select it, keeps the randomness constant. So first time when you select the data, right? So let's say, actually, if I ask you, you can pick any of these samples and probably more, right? But fixing the randomness means once you run set.seed, your split sample.split command will pick the uh, numbers, or sorry, pick the observations randomly first time, and then it is going to fix that randomness, so that even after 5 days or 10 days or 20 days, suppose you come back on this model, right? You will pick the exact same observations. If I pick this model, if I pick these observations using set.seed, right? Along with set.seed, I run this. I am going to pick the same observations. Are you getting it? Otherwise, if you don't pick the same observations, how can you actually test the accuracy of the model? Every time the accuracy will change because there is a new data, isn't it? And models, they require a lot of iteration, to and fro movement. You are testing the model. You have created the model today. You will test it tomorrow. Then you will test it maybe 2-3 days back. Some of the other person in your team, he is also testing it, right? But unless and until you are going to fix this randomness, every time they run it, they will come up with a different samples. Is this point clear? Set.seed, what does it helps in? Fixing the randomness of the data selected. Is this point clear? Set.seed, right? Okay. So using sample.split, what I do is, I'll quickly wrap it up here, right? Sample.split, I mention the data and I mention the split ratio, right? And I put this in a variable called sample. I'm sharing this also so that now once you have, now if I run sample, see what will, how, let me run this. A fixed set of training set, will it not overfit the model? Alok will talk about overfitting. No, 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 it will not overfit. See, fixing the training data, fixing the randomness, not fixing the training data, right? We are not, we will be testing it on a different data, right? Are you getting it? Testing is going to happen on a different data. Okay, so overfitting happens when you just try to build try to chase only the accuracy, right? That I want 80% accuracy. Then you make some iterations, you keep on building the accuracy 80%, 90%, right? And you are in regression, we say we overfitting happens when I'm just chasing R square. You know what R square is, right? I'm just talking to you right now, right? Because R square gives you the accuracy of the model, right? So when you just chase the accuracy, then it is overfitting, right? Okay, okay. We'll talk about overfitting tomorrow, right? For now, if have you run this sample, created the sample, and now when you've created this sample.split and you run it, see how the output looks like. True false means it is 75% true and 25% false. Now what I do next is I create a subset where I mention that sample is equal to true. I put them into train data. Okay, using subset, I am saying go to diamond data and where sample is equal to true, put them into train data. Similarly, use subset, go to diamond data where sample is equal to false. You put them in test data. Is this clear? And this way I have created two data set, test and train. I want to check the structure. See the diamond, check the structure of the diamond. If you remember, it's 53,940 rows. Check the structure of training data. 42,000. Some ticks, 42,000 rows. 42,126 rows are put in train data and test data. The remaining 11,814 are put into test data. Is this clear? How do you do cross validation? Right? So we'll hold on today, hold at this point. We'll just stop at this point. And tomorrow we are going to start with regression. Okay? It will completely occupy tomorrow's, session. First model we are going to create is regression. And we are going to not only understand the concept, we are going to understand the output, interpret the output, right? Ashwini, please share the document link that you have shared yesterday. There you go. There is the document link. Okay. These are the session 5 script files already there. Okay. Thank you. Then see you tomorrow, same time. Okay. Take care then.
you for a wonderful session. So thank you everyone for your participation. You have shared a feedback survey from your browser. If you like the session, please rate us 5. For anything less than 5, please share your comments to help us understand what went wrong. It will help us to improve in upcoming sessions. Thank you for all your time. Take care.